This episode of Fluid Power Forum is sponsored by eShipping, a distribution chain management company offering transportation, warehousing, and technology services. Learn more at eshipping.biz.
Absolutely. I think, fluid power is a great source of energy and automation. It's, like I said, it's robust, it's simple, and it's repeatable. I can't say enough about it. I think it's just a great way to get things done.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, as always, we ask that you follow us on Twitter. You can find us there at the NFPA. And make sure you share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is, in fact, one of the ways that we source topics for our show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. We're on Apple Podcasts. We're on Spotify. We're on a lot of the other podcatching services. Wherever you find our show, subscribe and then give us a quick rating. Those ratings really do help more and more of our friends in the industry hear about the show and join in on these important conversations. On today's show, our guest is Jesse DeSanto. Jesse is a National Product Development Manager for Cobots and Soft Robotics at SMC Corporation. And SMC is a leading manufacturer of pneumatic control devices for automation. And today we invited Jesse into our forum to learn more about Pneumatic Cobots and the ways that they are ensuring accurate and repeatable results in medical industry automation. So Jesse, welcome to Fluid Power Forum.
Welcome. Thanks so much for having me. I appreciate it.
We're glad to have you on the show today. I always ask our guests to tell our listeners a little bit more about themselves. How'd you find yourself working for SMC?
Well, actually, I went to school at Rochester Institute of Technology, and one of my friends had just gotten a job with SMC, one of my fraternity brothers, and he was like, we're having some openings here at this new company. It's really growing. It's pretty dynamic, and I was fortunate to get into a training program where you started at the ground up. So I started up being in the shipping and receiving department, worked my way up to inside sales and outside sales, and kind of kept growing with the company.
Great.
It was a really good opportunity. I'm so glad to do it.
And you picked up fluid power along the way, or that was part of your schooling at Rochester Institute?
Well, actually, I had no idea anything about fluid power before I came to SMC. And when I kind of realized and learned about it and all the different industries it's in, and it's just really cool to watch the machineries flow with air and what they're doing. And it just really sparked my interest because I've always been kind of a mechanical guy. I've worked on my own cars. I've always been able to really kind of relate to mechanical apparatus. So it was really a good fit for me.
That's great to hear. I mean, I'm always amazed that, mechanical people like you described yourself as, like to tinker with things and they like to figure out what makes things work. And there are some things you can't make work without fluid power. It's
absolutely.
It's one of the key technologies, and there's so many people who just aren't familiar with it. So I'm glad you stumbled your way into it, it sounds.
Oh, absolutely. I was very fortunate because until you're actually in the field, you have no idea how many industries it touches.
Exactly. And SMC is a company that's in a lot of spaces. Can you tell us a little bit more about SMC as a company?
Yeah, we're actually the largest automation component manufacturer in the world with about 38% global market share. We produce pneumatic, electric, instrumentation, hydraulic, temperature control units, air preparation equipment, just a wide product line. We have actually 54 sales offices in Japan, 6 factories in Japan, 29 factories in other countries around the world, and 532 sales off in 83 countries and regions. So it's a very vast global, truly global company.
I was not aware that SMC made hydraulic equipment. That's at least news to me. Is that new to the company?
Well, no, actually, it's a smaller segment, and it's based around typically the JIS standard. You probably won't see much our hydraulic components here in the United States, mostly in the Asian region.
Okay. That's probably why I haven't bumped into it. I know mostly SMC from what's going on here in the United States. So,
oh yes, yeah.
And so it's mostly automation products, as we've described. What kind of markets is that for SMC? Where will we find SMC products?
You'll find this everywhere, from semiconductor to automotive, food and packaging, machine tool, medical device, resource projects, wastewater treatment plants, and photovoltaic. So we're very a broad base of industries out there.
A lot of different, as you said at the beginning, a lot of different applications people aren't aware of. Fluid power is everywhere in so many ways.
It really is.
Yeah. And one of those markets must be cobots. I mean, that's something we wanted to talk about more on our show today. And maybe it's best to start with a definition of that term. I'm not sure everybody knows what a cobot is. So, Jesse, what's a cobot?
Okay, a cobot is short for collaborative robot. Mm-hmm. It's a six-axis arm, a smaller six-axis arm, that's meant to work side by side with humans to help them, and not to make them help them be more efficient, and not take their jobs like a traditional industrial robot would do. Like I said, there are six axes, which are comprised of six-axis servo motors that work in conjunction to move around to do work.
Yeah, they really are becoming much more popular. I see them in more and more factories that I find myself in. And as you said, they interact directly with the human, right? They're not behind some industrial cage like a lot of other industrial robots are. So that must give them some popularity. They're becoming more and more popular. Why do you think that is?
Well, okay, there's a couple reasons. First of all, they are much less costly than a traditional industrial robot. Mm-hmm. They're probably about a third of the price, depending on what you're going to use it for. So they're less costly. They're much easier to program. You can hand guide them to program by using a simple pendant, as opposed to lines of computer code, which is it's more sophisticated, right?
Right.
The thing about them is like when you're using them, they don't go at the fast speeds, say, an industrial robot does. So if there's ever a collision with a human, it's not going to create damage. But having said that, you always have to do a risk assessment, because depending on what the application is, you always want to take care of that. So that's something to be cognizant of it. Another thing too, since they're smaller, they can be moved around the factory more and repurposed. So you can use it for, say, a pick and place application in one part of the factory, right, and then maybe you want to move it around and have it do an inspection for another part. So they're multifunctional too, and that makes them more attractive to customers out there in the marketplace.
It sounds like they're much more versatile, that they're easier to reprogram or repurpose for new tasks throughout the day. Do I have that right?
Absolutely.
Yeah.
And so like traditionally, like when you have an industrial robot, once you do it, set it up, and you have it running on on a production line, you're not going to move it. Now, it can be retooled if you actually have to over a period of time, but that's going to take a lot of time and a lot of different setup, where a Cobot's much easier to do. You can get them going out of the box in probably like an hour, setting them up and getting them ready to go.
And you mentioned pick and place as kind of one of the primary tasks that they would perform. Are there other kind of common tasks that Cobots are focused on?
Yeah, the biggest ones, like I said, are the pick and place, palletizing, packaging, electronic assembly, inspection, and a real big one is machine tending, where Haas lathe or a machine tool, a Mazak machine tool, loading and unloading parts. So, for example, going back to the efficiency, you could have an operator working on two machine tools and having the Cobot load and unload, and maybe having the worker doing something else, get it set to another function. So you're actually making the person almost one and a half times more efficient.
Right. As you said earlier, they're kind of really designed to be, companions to a human worker rather than a competitor, right?
Yeah, that's the big thing too, because think about this. I think of them as just a high-tech tool, right?
Mm-hmm.
So you have somebody that's doing a repetitive task, monotonous, boring in a manufacturing cell. So, they could actually probably increase your morale. So if you're setting your Cobot up, it's helping you with this function. You could do something else that's different, maybe a little bit less repetitive, less, say, injury provoking, such like carpal tunnel or something like that.
Right.
So, they could be looked at as a positive force to your workforce, because they know they're not going to get their jobs taken away.
Right. Yeah, they'll kind of do what you tell them to do, and do it efficiently and effectively, right? It's like the dream worker in
Absolutely.
in a lot of ways.
Exactly.
Be careful with that. I might get in trouble, depending on who's listening. So, but clearly this is a fluid power show. There must be fluid power on these Cobots, and SMC is mainly pneumatics, as we talked about. What kind of pneumatic products do we likely see on the Cobot application?
Well, we actually have 3 pneumatic products that we use currently right now. We have a 2-finger air gripper that uses, just a pneumatic piston. That how that operates is you have air pressure on one side of the piston or the other to drive it back and forth. So the pneumatic gripper has a linkage system to open and close the jaws.
Right.
So we have that to be able to pick in place. Then we have a magnetic cylinder gripper, which is a magnet attached to a piston rod that moves back and forth inside the cylinder body, that once it goes down, it can create a magnet force and picks up items, so you can use it like a pick and place like that.
Right.
And then also we have a vacuum gripper that uses compressed air, goes through a Venturi vacuum that creates vacuum to be able to pick up the part and move it to where you want it, and then drop it off by just a little bit of a blow off to be able to escort the part to where it's going. So we have three products right now that we're looking to expand upon, but right now all of our current products are pneumatic based.
And we'll see, as you said, so those are, I think they call that end of tool fixtures sometimes. That's like the
yes, end of arm tooling. That's right. Correct.
So that's primarily where we would see the pneumatics, is the force and the control necessary to pick something up and drop it off through one of those gripping mechanisms you talked about.
That's right. And the thing about this that I like about our products is they're simple. So, they have a couple of solenoids to be able to turn on and off, which is going to change be able to open or close, or, create vacuum, not create vacuum. They're very simple, so that means they're very easy to troubleshoot. Mm-hmm. And typically, a lot of the functions that these Cobots are going to be on are pretty simple, like picking and placing the specific parts, no matter what they may be. So if you have a smaller or mid-sized company that doesn't have a ton of engineering support, this would be simple enough to learn and be able to increase the throughput of your factory. So that's why we like to use pneumatics. It's simple and it's robust.
Yeah, and it is in a lot of different applications as well. So it's good to hear that that's true in the Cobot world as well. And Jesse, we're going to want to talk.
Absolutely.
We're going to want to talk some more about some other advantages that pneumatics has for this application. But we've reached the point in our show where we want to take just a short break so that we can fill in our listeners on NFPA's latest edition of the U.S. Fluid Power Industry Brief is now available for download from the NFPA website. The brief is a convenient compilation of industry facts and data which can be used to understand and promote the growing fluid power industry. You can use the brief to encourage a student to pursue a career in fluid power, to educate your network on the value of your business and industry, or just better explain to a family member what it is you do and why you love it. To view and download the brief, head to nfpa.com and look for the U.S. Fluid Power Industry Brief under the Industry and Stats tab. Go there now, download that file, and share it with anyone you think would benefit from our content. Working together, we can promote and grow the fluid power industry. Some other opportunities available to them in the fluid power industry. All right, we're back from our break. I'm speaking with Jesse DeSanto of SMC Corporation, and we're talking about the advantages of pneumatics in Cobot, collaborative robot applications. And Jesse, I was going to ask about cleanliness. I know pneumatics is often sought after because it can operate in very clean environments. Is that an issue in Cobot applications?
Yes, it's something that always has to be considered. There are a few cobots out there in the market that are IP65, 67, and some that are actually clean room rated. So from a pneumatic system, if it's going to be in a washdown, you're going to want to make sure that, depending upon where the controls are for the pneumatics, that obviously they're going to be guarded. So they're not going to be able to have any type of ingress progression into the circuits to be able to, to make them not work.
Right.
Obviously, if you're doing cleanliness, you're going to have food grade materials, seals, and lubricants to make sure that, obviously there's no any type of contamination on the product that you're picking up. So it absolutely has to be a consideration. There's quite a few countermeasures you can take to make sure of that, for sure.
Yeah, I guess I hadn't thought about cobots in food processing applications in the past. That at least it seems novel to me. Is that common, or is that fairly new?
It's coming. Well, it's coming down the road. I mean,
yeah.
There's actually a couple of cobots that are getting into actually frying foods and flipping hamburgers and frying French fries.
Yeah.
There's also ones that are serving drinks, baristas. So it's becoming more and more, and I think it's going to even grow more in the future as maybe we have the issues with our labor force, getting people to work in those types of jobs. So I think it's only going to grow, to be honest with you.
Yeah, well, that's interesting perspective. Yeah, I haven't seen it at my local Starbucks yet, but I'm one of these days they'll be making a Cobot will be making my Frappuccino, I guess, right? So
I think so.
Seems to be the way we're going. As long as they're using pneumatics, that's okay with me. So we are a fluid power focused show. So
I think there's always going to be a spot for pneumatics because it's easy, it's robust, and especially if you're dealing with a workforce that might not be, like I said, degreed engineers. It's much easier to troubleshoot than electrical components.
So there must be a pretty robust set of sensors on these applications, these cobots, so that they can perform the functions that they need to perform. Can you talk to us a little bit more about how that works?
Well, so they have like force and torque sensors. So, it's set so they can't typically, cobots are not going to move faster than 250 millimeters per second. Because if you go anything faster than that, you can create a collision that could probably hurt somebody, right?
Yeah.
So, they have monitor stops, hand guiding you can hand guide everything to the location you want. The biggest things as far as when a Cobot, you come into contact a Cobot, you have to use some type of a light curtain or a pressure mat if you want to have the robot stop completely. So that's always something you have to be cognizant of.
Right.
There's also some ISO standards. There's ISO 10218 and the RIA TS 15066 that are the standards that define the safety in more detail of what the forces, the loads, and everything you can do with the Cobot. But there are definitely some very intricate circuits into there.
Yeah. It sounds like there's a lot of intelligence packed into a small package for these to work safely and effectively. Yeah. I said at the introduction, Jesse, that we were going to talk a little bit about the medical applications, cobots in the medical industry. Is that similar or somewhat unique to all the things we've already talked about? What kind of tasks are these cobots pneumatically enabled doing in that industry?
I was actually at a show in Boston a few months ago,
mm-hmm.
and in the medical industry, for what I'm seeing, the biggest applications from a medical standpoint are sample handling of reagents, and, samples being picked and placed from one location to another in some type of an analyzing device.
Mm-hmm.
So that's good because you can control the speed and how delicate, depending on how the sample is you have, right? You don't want to have it being, haphazardly taken from one area to another. So that can totally be controlled by a Cobot. You know exactly how it's going to be every time. So you can control the process. And with any type of application like that, controlling the process controls the quality. So that's a big link. And that's the biggest kind of application I've seen for those used so far, for sure.
Well, and it sounds like, again, that cleanliness issue would come into play there more so than some other places. You have to keep those things clean.
Absolutely. I mean, that's one of the things, like, it's extremely critical. You don't want to have any type of contamination when it comes to a medical device or certainly a sample, because that's somebody's life you're dealing with, right? Test results. So you absolutely have to be 100% on the money on that.
And you talked about the fine control that is sometimes needed to precisely pick and handle in place, those very delicate agents that you've described. A lot of folks try to do that with electric or electromechanical processes. Can you talk at all about kind of the pros and cons of using pneumatics as the solution rather than electrics?
Well, it depends on the accuracy that you need. So if you're looking for something simple, very cost-effective, and more repeatable than a human, then pneumatic is the way to go. So if you need something that's more accurate and you want to have multiple positions to grip something on, then electric is the way to go, but you're going to pay a lot more money for it. So there's trade-offs. And a lot of times, in these applications, you're only, picking up one thing at a time. You don't really have to worry about the variability.
Right.
So to me, it seems you want to go with something that's cost-effective, repeatable, and simple and easy to troubleshoot.
Right.
But electric has its place too.
Yes. Well, I mean, we're not trying to conquer the entire market for pneumatics, but
understand completely.
But it's important to understand those distinctions, because I think I often, as our common listeners will know, that I often ask our guests about, and I asked you about how you found your way into fluid power, and a lot of people who have formal training in engineering or in other technical disciplines don't learn about fluid power, so they kind of have an other technology bias when they come to solving some of these problems. So it's important to kind of spell out, when is the best time to use fluid power, or in this case, pneumatics, as that solution.
That's funny because, like I said, I went to RIT and I graduated with a packaging management science degree.
Yeah.
But we have a couple of kids that graduated as engineers from RIT, and they really didn't understand pneumatics or really taught it that much to the degree that we teach it here. So it's funny that you say that. It's kind of like a forgotten science in a way.
Yeah. When you say teach it here, you mean at SMC, right?
Yes, we have a sales academy that does really well. We bring them in, our people in for like 6 months. They learn all about our product. They learn the basics of pneumatic, and then obviously how to present yourself and how to be a professional salesperson.
Yeah.
So it works out very well for us.
That's great. And you're a product of that process yourself. I know that SMC is not the only company in our industry that does that, because again, they need to educate their own employees in this technology. So it's a great place to be as a result.
Absolutely.
So another question I had, was if somebody's out there and they're interested in using pneumatic cobots, but they already have robots in their factory or in their application space, is this the kind of thing that existing things can be retrofitted to, or you have to kind of wipe clean and start from scratch? How does that work?
Well, I mean, it'll all come down to the application. So say if they want to replace an existing robot line and they figure that they can do it with cobots, obviously there'd have to be, some planning involved, but they could probably do it pretty quickly with the fact that the cobots aren't going to cost as much money from a capital equipment standpoint, right? And then as far as a programming standpoint, it's not going to take them that long to get it up and going. And then from a space standpoint, it's not going to create, the space constraints, because all of the guarding that you need with a traditional industrial robot. Right.
That's great. I'm wondering, like so your role is to design and apply the technology onto these cobots. I mean, SMC doesn't sell cobots itself, right?
That's correct. We sell the end effectors, and my job is kind of act as a liaison between our sales force, our customers, and our engineers to figure out what products we need to develop, improve upon the ones we have, train our sales force, and help drive sales. So, and then also work with marketing from a promotional standpoint. So I love it because it's a little bit of everything.
Yeah. So in this space, your customer is actually the cobot manufacturer, I guess, would be the way to think about it.
Well, Cobot manufacturer, and then on top of it, systems integrators, because what'll happen is
right.
The Cobot manufacturer sells to a systems integrator that does the application. And in the application, they could be, like, say, you need a vacuum gripper, a magnet gripper, or a just standard two-finger pneumatic gripper.
Yeah. I guess what I'm trying to get to is I want to know if you have any feedback from the market through that customer channel. I mean, in terms of how these cobots are being applied and kind of what their strengths and advantages are. Do you have any feedback from your customers on this?
Oh, absolutely. I mean, a lot of customers, they're very well received in the market. The one thing, though, is it all has to come down to the right application. Mm-hmm. You know, because obviously cobots also have like a weight. They can't pick up the weights. Usually 35 pounds or less is what they can pick up. They can't move as fast, and they're not as, 0.001 millimeter accuracy as an industrial robot. But it all comes down, like I said, about the application and finding the right fit. And when they find the right fit, they do great. And customers love them because they're easy to program, they're multifunctional, and they don't cost as much. And it's not like when you set up like a robot line, once you set that up, I mean, you're taking up a big chunk of space, a big chunk of real estate, and you can't really move it around after that, So they're very flexible. And I think the smaller, mid-sized companies are good for these types of products because it's their first step into automation. It's not that big of a risk, and they're easy to work with.
Right.
They don't have to have the engineering know-how to the degree, say, of having, like, say, 10 industrial robots on the floor.
Right. It sounds like you're pretty, what's the term, bullish on this? You think there's a lot of expansion in this market to come?
I really do. And the reason I think what's going to happen is, as we become more efficient and, having issues with getting people into the workforce and working jobs that maybe, after a while, I mean, certain manual labor is going away, right?
Yeah.
So one thing you can do is you can take the jobs away completely, which is not going to really be the answer, right? You want to be able to get tools out there that people can use to be able to become more efficient and help them. So I think there's going to be a gap in there, and we're going to still see growth and have a happy coexistence between cobots, people, and industrial robots.
Yeah. Do you see moving into any kind of new markets or new industries, this kind of technology?
I think that there could be opportunities for in agricultural and logistics, right? And the food service industry, I think there could be a lot of growth there as well. But, things have to be worked out. You have certain standards you have to hit. So you just got to make sure it's going to be right before you go into that. But I think those three markets are going to be really big in the future.
That's great. Yeah, well, it's certainly something we'll keep an eye on, and I'd be happy to see this happen because, again, it's getting more fluid power out into more spaces is a really important part of efficiency and effectiveness in our marketplace.
Absolutely. I think, fluid power is a great source of energy and automation. It's, like I said, it's robust, it's simple, and it's repeatable. I can't say enough about it. I think it's just a great way to get things done.
That's great. Well, Jesse, thanks so much. We're going to let things end there and wrap up this episode of Fluid Power Forum. My thanks again to Jesse DeSanto of SMC, who has been my guest. If you'd like to connect with him, learn more about what he does and about this interesting area, you can do that by his email address, and we're going to put a link to that email address in the show notes for this episode. Remember, if you like our podcast, please remember to follow us on Twitter. You can find us there at the NFPA, and keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. Also, to see the latest fluid power technology and learn from industry experts, you can make your plans now to attend IFPE, the International Fluid Power Exposition. Our next show is March 14th through the 18th in 2023 in Las Vegas, Nevada. For more information, visit ifpe.com. This is Eric Lanke of the National Fluid Power Association, reminding you to join us next time in the forum.